Uh, Good evening, everyone. And my name is Tianqi Jia, and I'm from the College of Resource and Environment at the University of Chinese Academic of Science. And today I will be discussing the occupational expose of Nile salon worker to the organic phosphate ester. Organic phosphate ester are commonly used as the flame retardant and plasticizer in various of products. In 2017, the global market for OPEs was valued at over $1.7 billion, with an expected increase to nearly $31 billion by 2025. And OPEs are typically added to the materials as additives, not chemical bonded, allowing them to release gradually into the environment. And based on their structure, they can be divided into chloroalkyl, non-chloroalkyl, aromatic, and some novel OPEs. And unlike the traditional persist organic pollutant, it has been found in some animal experiments that some OPEs can readily converted to the diester or metabolize. Some OPEs have been confirmed to show various toxicity effects, such as the carcinogenicity, reproductive toxicity, and the neurotoxicity. And as the flame retardant, OPEs are primarily used as alternative to PPDE. And as the people's understanding of them deepen, the United States, the Canada, and the European have implemented regulation to restrict the use of certain OPEs. And the other usage of OPEs is in the nail polish. TPHP often used in place of DBP to make up many nail polish formulas. A study in 2015 found that over half commercial nail polish have detected TPHP, and in recent years, some companies have introduced labels such as 7-free and 10-free, indicating their nail polish do not contain TPHP. However, regulation and enforcement of nail polish still remain limited. And considering the primary use of nail polish are women, including a large number of women in a childbearing age, due to the relatively short time that OPEs have been used in nail polish, related research is very limited. So the main objective of this study is to first investigate the concentration and the distribution of OPEs in nail polish, along with this emission rate and emission mechanism. And the second, determine the level of OPs present in nail polish, including understanding the pathway on their migration and transformation. And the third, identify the factor that in fact influence OPs in nail salon environment. And finally, to assess the internal exposure and associated health risk of OPs for the worker. So the first part of this study involved selecting 40 bottles of nail polish based on their popularity from 10 nail salons. And these nail polish were categorized as the no label, 3-free, 5-free, 7-free, and 10-free. And after analyzing this nail polish, 12 nail polish were random selected and placed in volatilization device to analyze their emission rate, and then put the emission rate into the model to investigate the migration and the transformation. And this is the sample preparation and analysis process. And the results showed the concentration of OPs in nail polish range from 0.38 to 1,254 microgram per gram. TPHP was detected in all samples with its highest concentration on average accounting 87% of the total concentration. And nail polish can be divided into 3 categories based on its composition. The average concentration of OPs in the oil-based nail polish is higher than that in the UV nail polish or the water-based nail polish. And we also find that the concentration of OPs in nail polish was significantly correlated with the price. And we think the more expensive nail polish had the higher color richness, and TPHP may play an important role in the color rendering, ductility, and the durability of the nail polish. And a comparison with the study over the past decade shows that our study was very lower than the previous report result. And as the public awareness regarding the hazard of TPHP increased, some manufacturers took steps to reduce this percent in the nail polish. However, many manufacturers label their product as TPHP-free. We still can find high concentration TPHP there still in nail polish. And now, after we knowing the concentration of OPs in the nail polish, the next question is how they emitted from nail polish into the environment. So we put nail polish into the volatilization simulator and find 2 minutes after the nail polish application, the emission rate was as high as 1,320 nanograms per hour. And the volatilization of OPs in the air decreased by about 62% after 30 minutes, and after about 77% after 1 hour. And when doing the manicure at home or in the nail salon, this process usually lasts more than 1 hour, which is also the repeat volatilization period of the OPs. And compare with the other study, the emission rate of TPHP from the nail polish was notably higher than that from the building insulation materials. Such emission rates can impact the indoor environment during the daily usage. Therefore, it is reasonable to considering nail polish as an important source in the nail salon. And then we put the emission rate into the model to predict the OPE's concentration in the air and the dust within the nail salon. 2 minutes after application of nail polish, the PEC in air is 582 nanogram per cubic meter, and in the particulate matter and the dust were 148 and 33 nanogram per gram. And after OPs in the air, after 1 hour, decreased by 77%, accomplished by an 80% decrease in the particulate matter and the dust. And after 24 hours, when the nail workers start their shift to the next day, and the OPE will decrease about 96%. And it is noted that OP has a residue of about 5% even after 24 hours, and this residue will accumulate day by day. And to validate the model output, we collected the air and the dust sample from nail salon for analysis the review literature, and the measured concentration of OPs in the air of the nail salon was found to be comparable to the model output, whereas the concentration of OPs in the dust was lower than the model prediction. And we think it may be because the nail salon required to cleaning the dust generated after each service, and it will leading the actually test concentration of OPs in the dust being lower than the model output. And we also find the air exchange rate is a key factor in the model output, so it's recommended to validate frequently when applying the nail polish. And taking TPHP as an example, the model explained the distribution and the migration transformation pathway of OPs in the nail salon. After being emitted from nail polish, TPHP tended to bind with the particulate matter and settle on the table, carpet, and floors. So besides the above suggestion, we also recommended cleaning carpet and floor to prevent the high concentration of OPs in the dust from returning to the air. And we calculated the human exposed assignment using the formula recommended by the EPA. Within the 30 minutes of applying nail polish, the CR value indicating a potential cancer risk. So we strongly recommend to ensure proper volatilization during the nail polish application and the timely cleaning of the dust generate. So now we know the concentration OPEs in the nail polish and how they release from the nail polish into the environment. So what is their impact on the workers? In each salon, we selected one worker to collect their mask worn during work hours, and we collected a urine sample before and after work. And additionally, the air and the dust sample from nail polish were collected. And the total concentration of OPs in the air ranged from 251 to 1,007 nanogram per cubic meter, and in dust ranged from 371 to 14,473 nanogram per gram. TPHP concentration in the air was higher than that in the Canada and American nail salon, and lower than in the chemical manufacturing plant. We also find the urine concentration of TPHP and the DPHP after work were on average 5 and 2 times than those before work. And it is in 2 nail salon, urine TPHP concentration after work were 19 and 13 times greater than those before work. Notably, the 2 nail salon also have the highest concentration in the mask and air among the nail salon. So our finding indicates that nail polish worker may experiment considerable occupational exposure to TPHP and DPHP. Mask can serve as a protective measure to effectively reduce the inhalation of OPs, and the average protective efficiency of the nail salon worker was 77%, and this finding highlights the mask's efficient ability to capture the OPs and provide the protection to the staff. So it is important to note that in the case of the 2 nail salon with prolonged 13 working hours, their mask become enriched with the high level of OPs, which could potentially release and inhaled by the worker. So we also recommended frequently replace the mask. And with further analysis involved to identifying which factor might contribute to the occupational exposure among the workers, Spearman correlation and cluster analysis were performed between the OPs concentration and the characteristic of the nail workers. And the result showed is after work urine TPHP is influenced by the nail polish usage, the TPHP in the air, and also the TPHP in the mask. So this study comprehensively investigated the nail salon worker exposed to OPs from the source to the environment and finally to the worker internal exposure. And given that many nail salon workers are young women of the reproductive age, more attention should be paid to the occupational exposure of nail salon workers to the OPs. And that's my presentation. Thank you for your time.